awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Okey, jadi sekarang awak dah selesaikan soalan-soalan dalam video set 1 part 1. So kali ni kita akan proceed bagi set 1, masih set 1 tapi part 2. Di bahagian ini kita akan sambung question 6 to question 10. Alright, so question number 6. Look at here, we have 6A. So we have A. We have an object is placed 35 centimeter in front of a converging lens. So when we talk about converging lens, means that it refers to the convex lens. If diverging lens means that concave lens. So diverging lens means that concave lens. Alright. So this is about lens, converging lens, concave lens. Remember, ini paling penting you kena tahu that for the focal length for the convex lens, the focal length is positive value. And ingat salah satu lah. So for lens, convex lens is positive value. Concave lens, F is negative. Tapi untuk mirror, concave mirror, positive value of F. Convex mirror, negative value of F. And remember, untuk lens, all real image. Untuk lens lah. Untuk lens, real image is formed behind the lens. For mirror, all real image for mirror, ataupun awak ingat salah satu lah, all real image for lens form behind the lens. Tapi kalau untuk mirror, virtual image yang form behind the mirror. Itu benda yang you kena ingat. So for the convex lens, for convex lens, we will get the different type for convex lens, we can get different characteristic of image, and it depends on the position of the object. But for concave lens, the only characteristic of image that we will get is, ini kena ingat penting juga, virtual, upright, and diminish. Maknanya kalau concave lens ini saja, kan? Tapi kalau untuk mirror, karakteristik ini, yang tiga ini, dia adalah kepunyaan convex mirror. Convex mirror, bila cerita pasal convex mirror tu dah tahu dah dalam kepala. Oh, image yang terbentuk mesti virtual, upright and diminish. Kalau cerita pasal concave lens tu dah tahu dah. Image yang terbentuk adalah virtual, upright and diminish. Alright, so let's proceed to question number 1. So you dah bagi 35 cm and the focal length is 8 cm. Sketch a ray diagram of the image. So bila you sketch a ray diagram, make sure scale pakai tu, nisbah ada tu dekat kertas, ukur betul-betul guna pembaris. Tak perlulah awak nak ukur U sampai 35 cm kan. Paper kita kecil, tapi nisbah tu saya masukkan tu. So sekarang kita ada converging lens means that convex lens. Sekejap saya buat line. So kita nak buat convex lens. So contoh saya ada macam ni lah. Straight line. So saya ambil saya punya lens saya. Dari hitam lah. Contoh lens saya duduk kat sini. Macam tu lah lebih kurang. Macam tu convex lens. So saya akan letak F ni ukur dah betul-betul. Kalau guna sini F 4 cm, Dan belakang ini pun mesti 4 cm. Okay, ukur pembaris tu betul-betul. Okay, and then agaklah when U is 35 cm, okay, means that the position of the image, okay, for example here, for example here, okay, so this is image, jauh sikit lah daripada F sebab 35 cm kan. Okay, so now let's draw. Okay, bila lukis arrow jangan lupa lah. Okay, so parallel to the axis. Okay, first ray, okay, parallel to the principal axis. Boleh. Okay, and then dia akan pergi ke mana? Ini besar sangat ni kita punya. Macam tu lah. Kita tak edit. Okay, lebih kurang macam tu lah. Okay, so second one, dia akan pergi ke sini. Terus pergi ke C. Okay, alright. So, ia akan dapatlah image iaitu ke sini. Okay, so arrow jangan lupa bila lukis. Sekejap. Arrow, letak arrow. Cukup sekadar 2 ray saja. Okay, so image yang kita dapat sini kita boleh tahulah. Okay, now the image here is formed behind the lens, and look at here, it is diminished and inverted. Okay, so kalau kita label object and image, okay, daripada sini kita boleh tahu objek kita adalah apa? Real. Kenapa saya kata dia real? Sebab dia form behind the lens. Real, inverted and diminish. Okay, so satu lagi yang saya nak highlight, okay, remember that all real image, okay, must be inverted. Okay, inverted, INV tak muat saya nak tulis. Okay, all all virtual image must be upright. Okay, kedua-dua lah untuk mirror dengan lens. So kena tahu, all real image inverted, all virtual image upright. Okay, so number 2, calculate the image distance. So kita nak tengok lah berapa image distance from the lens. So image distance tu daripada mana ke mana? Dari sini lah, lens ke image ni lah. Okay, V. Ini tadi U. Kan? So kita nak cari V kita berapa. Okay. So 1 over F equal to 1 over U plus 1 over V. So F, make sure the value of F is positive because convex lens. Okay, so F is 8, 1 over 8 plus 1 over 35 plus 1 over V. Therefore, kira betul-betul V akan dapat 10.37 cm. Okay, so the value of V is positive value, means that the characteristic of the image, dia mesti real lah kan, sebab V is positive. Okay, so tengok sini V positive value, so dia adalah real. Real dia adalah behind lens. Okay, so number 3 tu dia suruh state 2 characteristic of the image. Okay, dia nak 2 saja. Bagi 2 saja pun dah cukup lah. Okay, so kita nak apa? Real, inverted and apa? Diminish. Daripada lukisan tu kita dah tahu dah. Real, inverted, diminish and diminish. Okay, so dapatlah jawapan. Boleh? Okay, so let's move to question 6B. Okay, 6B, we have the height of the object. It's given 12 cm and it is placed at 20 cm in front of convex mirror. Okay, convex mirror. Kalau tadi convex lens, F is positive. Convex mirror, F is negative value. Okay, so given that the radius of the curvature is 45 cm, okay, so from here, actually we can find the focal length. where f is equal to r over 2 and 45 divide 2 and it's equal to negative 22.5 centimeter. Okay, so letak negative because of the type of the mirror, dia adalah convex mirror. Now we want to calculate the position of the image. So this is very simple. Okay, position of the image. So 1 over f equal to 1 over u plus 1 over v. Okay, so 1 over 22.5, remember negative sign. 1 over 20 plus 1 over v. Okay, so kita akan dapat v is equal to, okay, v akan dapat berapa tu? Negative 10.59. Negative 10.59 centimeter. Okay, so negative means that, sorry. So the negative sign means that, okay, the image is virtual image. Kan? Image is virtual image and this is mirror. So maknanya the virtual image dia form dekat mana? Form behind the mirror. Terbalik tadi kan? Dengan lens, okay, image that form behind the lens adalah real image. So ini yang awak kena ingat. Okay, so the height of the image, okay. Sekarang kita nak kira the height of the image. Macam mana kita nak kira the height of the image? Okay, tengok sini. Okay, saya buat kat sebelah lah. Okay, so saya nak guna formula magnification equal to h of the image over h of the object. Okay, objek kita dah ada nilai dia. Kan? Kita nak cari sekarang ni yang ini. Sorry. Okay, kita nak cari ini height of the image. Tapi kita tak ada magnification. So remember, another equation of the magnification is equal to negative v over u. So kita bolehlah masukkan. Kita boleh tulis negative v over u equal to hi over h naught. Okay. So therefore, hi equal to negative v over u darabkan dengan h of the object. Boleh? So berapa? Negative v tadi kita dah ada negative 10.59. Okay, bahagi dengan u, divide u. U is 20 cm. Okay, times height of the object is 12 cm. Okay. Okay, 12 cm. Okay, kira betul-betul. Tekan kalkulator betul-betul. Therefore, the height of the image is equal to 6.35 cm. Okay. Okay. So, finish 6B. Kita ada pula soalan 6C. Okay, question 6C. Okay, tengok sini. We have the object where the height of the object is given, which is 5 millimeter. Okay. And the object is placed 35 centimeter. 35 centimeter. Okay, tengok unit betul-betul. So the object is placed 35 cm from the vertex of spherical surface of glass. So this is about spherical surface. Refraction at spherical surface. So what's the formula? Refraction at spherical surface. N1 over U plus N2 over V equal to N2 minus N1 over R. Okay. So this is equation of refraction, okay, at spherical surface. Okay, so apa lagi maklumat kita bagi? So the question state that the image formed inside the rod 50 cm from the vertex of the glass rod. Okay, V is 50 cm. Okay, saya tukar semua kepada meter. Okay, and given that the refractive index of the glass is 1.5. Okay, so mungkin rod dia macam ni lah, kan? Okay, so mungkin objek tu di sini. Okay, this is the object. Okay, so the distance here U. So dia dah kata dah, okay, the object is formed inside the rod. Okay, so this is the position of the image. Okay, which is 50 centimeter. Okay, is the image virtual or real? Alright, so look at here, the question dah bagi tahu dah that the image is from inside the road and it is behind, right? Okay, so this is the surface. So bila spherical surface, kita consider the characteristic to follow yang lens punya. So now, image ini behind the surface. Okay, it's from behind the surface. So image-nya adalah real ke virtual? Jadi kalau dia follow characteristic of lens, okay, image that form behind the lens, kan? Nah, kita dah belajar tadi, okay, the image that form behind the lens is a real image. Okay, so the answer is real image. And now we want to determine the radius of curvature of the spherical surface of the glass. Okay, so remember equation of the refraction at spherical surface. This is R, where R is equal to, okay, R is the radius of curvature. Macam tu. Okay, so kira R lah sekarang ni. Okay, so by using that equation, so N1 over U plus N2 over V equal to N2 minus N1 over V. So N1 is the refractive index, dekat mana objek tu duduk. Okay, so sekarang objek tu di mana? So this is the position of the object. Okay, dekat air, di udara lah, keluar daripada glass. Okay, so 1 lah, refractive index of air, 1. So U dia tadi soalan dah bagi, so it is 35 centimeter. Okay, plus, so the image form inside the glass, that's mean N2 is 1.5 over V, okay, where this is V, where V is equal to 50 centimeter. Okay, lagi, tolakkanlah, 1.5 minus 1.0 over R. Okay, ini macam V pula ni, tukar R. Okay, so this is V, real image. So jangan letak negatif pula, positif. Okay, so rearrange the equation. Finally, you will get the radius of the curvature R is equal to 8.54 centimeter. Okay. Okay. Finish question number 6. Okay, so let's proceed to question number 7. Okay, so now let's try to answer question number 7A and B. Okay, so for question 7, so here given that lambda, the light of wavelength 600 nanometer, is incident upon a young double slit. Okay, so this is about double slits. So here I've drawn the pattern of the interference on the screen. Alright, for the double slits. Okay, so lambda is given 600 nanometer. Okay, and the position of the double slits and the screen. Sebab dia bagi tahu the double slits which are 1.0 meter from the screen. That's mean D, capital D is 1.0 meter. Okay, maknanya kalau kat sini dia punya double slit. Okay, so the distance between, okay, the screen and the double slit is D lah. Okay, so ini adalah screen. Pattern yang kita nampak ni screen kita. Okay. Okay, the slit separation is given 0.3 millimeter. So small d is the slit separation, 0.3 millimeter. Okay, determine the separation between second bright and the fourth dark fringe. Okay, so bila soalan sebut second bright or second order bright, okay, senang kita tahu M is equal to 2. Tapi bila soalan sebut fourth dark, okay, untuk double slit dia kena tolak 1. Fourth dark, dark yang keempat, okay, M is equal to 3. Kalau soalan sebut fourth order dark, M is equal to 4. Okay, so look at here. So this is the central bright fringe. So here M is equal to 1. M is equal to 0. Okay, now look at here. M is equal to 0. So this is also M is equal to 0. M equal to 1, 1, 2, 2, 3, 3, and 4. Okay. So now, bila soalan kata second bright ataupun bright yang kedua. Okay. So this is the first bright from center. Allah. Okay. So from center, this is the first bright. And this is the second bright. So second bright ataupun second order, M is the order number, dia sama. M is equal to 2. Okay. So daripada tengah, from here to the second bright. Okay. So this is Y2B. Y2B saya tulis untuk rujuk kita. So I write Y2B because I want to guide myself that is the distance from the center to the second bright. Okay. So fourth dark. So we want to draw for the fourth dark. Dark yang keempat. Look at here. 1, 2, 3, 4. So the fourth dark is the order number. So the fourth dark is equal to M. Okay, so from here we know that the order number for the fourth dark is equal to 3. Okay. So here. So Y, okay, Y third dark. Okay. Okay, so this is Y. Okay, Y third order dark. Okay, the dark yang keempat tapi dia order yang ketiga. So the questions asks us to find the separation between second bright and fourth dark. Okay, means that we want to find this separation, okay, between fourth dark and second bright. Inilah kita nak cari berapa jarak ini. Okay, so kita kena tolak lah Y3D minus Y2B. Okay, kita nak buat Y3D minus Y2B. So 3D is the third order dark. So we substitute in the equation of dark fringes. So M plus half lambda D over D minus, okay, Y2B for the bright fringe. So make sure you use bright equation, okay, which is, okay, M lambda D over D. Okay. So don't forget this value 3 and this is 2. Kan? Sebab ini tadi dark. Okay. Third order dark. And this is second order bright. So 2 lah. Okay. Alright. So let's substitute all the values. So M 3 plus half lambda. So 600 nanometer. Okay. Okay, D is 1 and small d is 0.3 exponent negative 3 minus 2 times 600 negative 9. Okay, tak muat lah ni. Padam sikit. Okay, times 1 over 0.3 exponent negative 3. Alright. Therefore, the answer is equal to, awak kira ya, 3 exponent negative 3 meter. Okay, so this is the answer. Okay. Okay, so now for 7b, okay, so this is about thin film. Okay, so the question state that we have a thin film of polystyrene, and given the refractive index of the polystyrene is 1.49, is used as a non-reflecting coating. Okay, perkataan non-reflecting coating means that ini adalah kita punya clue. Okay, non-reflecting coating refer to the destructive interference. Okay, means that when we use wavelength of 620 nanometer, okay, we assume the wavelength of the light in air is 620 nanometer, and we use the thin film, okay, in order to cover, okay, to cover the fibulite. Okay, kita ada fibulite, alright, and this is non-reflecting coating, so this is referred to disruptive. Okay, disruptive interference. Kita guna thin film ni, okay, untuk kita wujudkan condition of non-reflecting coating tadi. Boleh? Alright, okay. So let's draw the layer. Okay, so this is air, and 1 is 1.00, and 2 is the thin film layer, polystyrene, so 1.49, and N3 is equal to, this is the fibulite, 2.409. Okay, so look at the interference. It comes from the lower refractive index to higher refractive index of 1.49. Oh, sorry. Okay, so means that there is a phase change. Okay, phase change from N1 to N2. So saya buat right. Okay, so for the second ray, okay, so the ray come from N2 to N3, sama juga, from lower refractive index to higher refractive index, so means that there is a phase change of ray 2. Okay, so sekarang both ray 1 and ray 2, okay, have the phase change, means that they are in phase. Okay, so means that the interference are in phase. Okay, so now use equation of interference. So now we will use the in phase equation and disruptive. Okay, in phase equation, disruptive. Okay, kalau nak ingat, I see madam, macam tu, I see madam. I see tu apa? Okay, so I for in phase. Kalau in phase constructive, C, M, okay, dia tak ada half, dia ada M saja, iaitu 2NT equal to M lambda. Okay, untuk yang ini, I see madam. Okay, so untuk yang satu lagi, anti-phase, untuk yang bahagian ini, A, untuk anti-phase, ini disruptive, dan formula dia ada M saja, tak ada half, sorry. Okay, cara nak ingat lah, nak hafal sebenarnya, I see madam, macam tu. Okay, so kita kena pilih formula in phase, okay, in phase and disruptive. Okay, so in phase constructive, 2NT equal to M lambda, right? So in phase disruptive, so the equation is 2NT equal to M plus half lambda. Okay, which is 2NT equal to M plus half lambda. Okay, so now let's write the, so now let's substitute all the values. So N is equal to 1.49 T, and M kita nak cari kan, what is the minimum thickness? So M we substitute 0 plus half, and lambda is equal to 620. Okay, 620 nanometer. Okay, therefore the thickness, the minimum thickness, okay, the minimum thickness of the film, okay, is equal to 1.04 exponent negative 7 meter. Okay, alright. So this is the answer. Okay, now question 7C, we have two questions here. Okay, we have a beam of monochromatic light of wavelength 589 nanometer. So lambda is 589 nanometer. Is incident on a diffraction grating. So this is about diffraction grating. Okay, so let's write equation of refraction grating. Okay, where D is equal to 1 over n. Okay, n is the number of lines per unit length. Okay, so this is the equation. So kita relatekan lah dengan soalan kita. So the question state that the second order maximum, okay, second order maximum means that m is equal to 2, okay, is formed at angle of 15 degree from the central maximum. Okay, that means the theta is 15 degree. So maknanya from the central maximum, okay, so bila angle is 15 degree, so kita boleh observe second order maximum on the screen. So now we want to calculate the number of lines per millimeter. So ulang lagi sekali, the number of lines per millimeter. So kalau you bagi jawapan the number of lines per meter, salah lah. Sebab soalan dah minta the number of lines per millimeter on the diffraction grating. Okay. So now, let's substitute. Okay, so D sin theta. So D is 1 over n. Kita nak cari n. So I substitute 1 over n. Sin 15 equal to m is second order maximum, where lambda is 589 nanometer. Therefore, okay, you can see here the value of n that you will get here is in meter, which is n is equal to 219.7 exponent 3 per meter. Okay, the unit is per meter. Macam ni kan? Sekejap. Okay, dia macam ni. Per meter ataupun lines per meter. So, soalan minta the number of lines per millimeter. So, we need to change lah. 219.7 times 10 power of 3 per meter. Okay, saya buat darab silang So, 1 meter is equal to 1000. Okay, 1000 millimeter. Okay, so now we can cancel. Okay, so therefore, the number of lines n is equal to 219.7 okay, lines per millimeter. Okay, so unit kita dah tukar ke dalam per millimeter. Okay, boleh. And C2, how many spectral lines could be observed on the screen? Maknanya berapa banyak lines ataupun bright fringes that we can observe on the screen. Okay. So 7C2. Okay. So in order to calculate the maximum number of lines that we can observe on the screen, we need to consider that the angle theta is 90 degree. So dia akan jadi sin theta, we assume it's equal to 1. Okay, so we will take this angle as the maximum angle, which is equal to 90 degree. Therefore, based on the equation of the diffraction gratings, so 1 over n sin theta equal to m lambda. So ini adalah 1. Okay, sin 90. So dia akan jadi m. So m equal to berapa tu? M equal to 1 over n lambda. Kan? Okay. So nanti dalam calculation ni, you masuklah nilai n. Tapi, okay, saya highlight dekat sini. Here must be in unit per meter. Okay, so kita dapat tadi berapa unit per meter tadi? N is equal to 219.7 exponent 3 per meter. Okay, so dia akan dapat 1/219.7 exponent 3 and lambda. Okay, substitute the value 589 point mana tadi? 589 exponent negative 9. Okay, so ini dah macam ni lah. Okay, so M is 7.75. Okay, 7.75. Cumanya saya nak highlightkan kat sini untuk the number of lines. Okay, tadi kan kita dapat ini kan 219.7. So tinggalkan jawapan, tak perlu bundakan 219 saja lines per millimeter. Okay, so ni jawapannya lah. Sama juga kat sini. 219 exponent 3 per meter. Kan? Yang tadi 219 lines per millimeter. Betul tak? Okay. So yang ni kita substitute lah. 219 saja. 219 and you akan dapat M is equal to 7.75. So kita kena ambil therefore okay, M jangan bundakan kepada 8. The number of order that we can observe is 7 order. Okay, jangan bundakan kepada 8. 7 order. Okay, so on the screen we have two side. Okay, let's say macam ni, tengah. Kan kita ada side atas dan side bawah. So this one you can observe up to 7 order. Okay, so dia ada central bright fringe and this is also 7th order. Okay, so kita kena consider jugalah yang tengah ni. Okay, so the number of order that we can observe on the screen, kalau tadi dia sampai 7 order. Okay, yang ni 7 tambah 1 bright tambah lagi yang bright 7. So kita tulis itu the number of spectra. Spectra tu yang kita boleh lihat lah, spectral lines. That mean the bright fringe. Okay, that can be observed. That can be observed. Okay, is equal to. Kalau you jawab 7, salah lah. Yang kita boleh observe on the screen, dia mesti ada atas dengan yang bawah ataupun kiri dengan yang kanan. Dia ada dua side. So 7 plus 7 plus 1. So the answer is 15. Okay, so finish question number 7. So let's proceed to question number 8. Okay, question number 8. So here we have a photon of wavelength. So this is the wavelength of the photon given 6.2 exponent negative 6 meter. Okay, where the photon emitted on a metal surface. Okay, so given that the work function of that metal surface, okay, ingat chapter ni. So we have photon, okay, where lambda is given and this is the metal surface. Okay, so given that the work function of the surface is 0.1 eV. Okay, so the metal surface is 0.1 electron volt. Find the kinetic energy of a photoelectron in electron volt. Okay, dia tak nak dalam joule. Okay, in electron volt. So let's write the general equation. So E is equal to W0 plus KE. So E is the energy of photon. Okay, W0 is the work function ataupun binding energy of the metal surface and kinetic energy. Okay, so therefore kinetic energy is equal to E minus W0. Okay, so we need to find first, okay, since we want to find kinetic energy in electron volt unit, so the energy of the photon is equal to okay, and lambda is equal to 6.2 exponent negative 6. Okay, so the energy of photon 3.21 exponent negative 20 joule. Okay, so make sure you change this into EV. Okay, where the electron, okay, is equal to 3.21 exponent negative 20 joule. And remember, 1 EV is equal to 1.6 exponent negative 19 joule. Okay, so E is equal to 0.2 eV. Therefore, kinetic energy is equal to E 0.2 eV minus work function is given 0.1. Okay, so 0.1 eV kinetic energy. Okay, so this is the answer. Boleh? And then for B, okay, look at question B. Okay, and the question is based on the graph. So figure 8 shows a photoelectric cell which is used to study the change in current with potential. Cathode is incident by a monochromatic light with a wavelength of 360 nanometer. Okay, so this is about the monochromatic light that incident on the cathode. Okay, determine the work function of the metal. So we want to find what is the work function of the metal. Okay, so from the graph, so let's write. Okay, from the graph, you can see that when I is equal to 0, okay, the value of I is equal to 0, okay, that means the stopping voltage is equal to negative 2 volt. Okay, therefore, E is equal to W naught plus KE. Okay, so this is general equation. Alright, where as we know, and you must know that the kinetic energy is equal to, okay, the charge of electron times the stopping voltage. Okay, therefore, okay, work function, rearrange the equation, is equal to E minus kinetic energy. Okay, and it is equal to HC lambda over lambda minus E Vs. So kita nak cari work function, right? So let's substitute all the values. 6.63 exponent negative 34 and C is 3 exponent 8 over lambda. Lambda is 360 exponent negative 9. Okay, minus 1.6 exponent negative 19 and stopping voltage is equal to 2 volt. Okay, therefore work function mesti dalam unit joule yang kita dapat ni, 2.33 exponent negative 19 joule. Okay, so finish question number 8. So let's proceed to question number 9. Okay, let's continue with question 9. We have an electron that has the Bernoulli wavelength of 2.8 exponent negative 10 meter. Okay, so let's write lambda is equal to 2.8 times 10 power of negative 10 meter. So determine the kinetic energy of the electron. So we want to determine the kinetic energy of the electron. So it's equal to half mv squared. Okay, so now we have a problem in order to solve for v. So this is the mass of electron, but we don't know what is the velocity of the electron. Okay, by using the Bernoulli equation for particle, which is lambda equal to h over p, and p stand for momentum. So lambda is equal to h over mv. So from here, v is equal to h over m lambda. Okay, so we substitute all the values. So h 6.63 exponent negative 34 over the mass of electron 9.11 times 10 power of negative 31, and lambda is equal to 2.8 exponent negative 10. Okay, and finally v is equal to 2.6 exponent 6 meter per second. Okay, so now let's substitute the value of v. Okay, so now let's substitute the value of v here. So kinetic energy of the electron is equal to half 9.11 exponent negative 31, and v is equal to 2.6 2.6 exponent 6 squared. Okay, so the answer is equal to 3.08 exponent negative 18 joule. Okay, so this is the answer. So finish question number 9. Okay, now we reach the last question. Okay, question number 10. So we have 10A here. Okay, so let's read the question. So an X element isotope with a half-life of 48 days decays into Y element. Alright, so given that the half-life of X element is equal to 48 days. Alright, so determine the time required for 60% of the sample of X element. So given that 60% of X element isotope to become Y nucleus. So 60% of X to become Y. Alright, so we can write that X, and then X will become 60% of X will become Y plus Q. Okay, so this is general equation. Okay, so we want to determine the time required for 60% of sample X to become Y nucleus. So remember, initially, so we have initial, okay, so initial nuclei, okay, we can write as n naught X, okay, so the number of nuclei for element X is equal to 100%. Okay, so initially the number of nuclei for element X is 100%. So after 60% of X element become Y nucleus, okay, the amount of nuclei for X would become 40%. So only 40% left. Okay, so we can write final nuclei for X, so I put as nx, will equal to 40% of its initial. Okay, and this is equal to 0.4 n naught X. Okay, so kalau initially tadi kita tahu, okay, initially the value of n naught X is 100%. Okay, so after 60% of X element become Y, so nx will equal to 0.4, okay, n naught X. Okay, and we want to and now we want to calculate time required, okay, time required for 60% of X become Y. Okay, so let's calculate this one. Okay, so let's write the general equation. N is equal to n naught E negative lambda T. Okay, so in this case, we want to find what is the time required for 60% of sample X to become Y. So we want to find this one, T. Okay, and remember, decay constant is equal to ln 2 over half-life. So substitute. So we have ln 2 over half-life is 48 days. So the decay constant is 0.01444 per day. So the unit is per day. Okay, so we can substitute here. Okay, so n is the final. Okay, so now let's substitute here. So n is the final number of nuclei for X. Yang tinggal berapa tadi? Which is 0.4 n naught X. So let's write the value. So 0.4 n naught X. And this is the initial value of X. And then the decay constant is 0.0144 per days. Okay, 0.0144. Okay, 444 and T. So this one we can cancel. Okay. And then take ln for the both side. So negative 0.01444t. Okay. Therefore, ln 0.4 equal to negative 0.91629. And it's equal to negative 0.01444t. Therefore, t, okay, t, the time required, okay, for 60% of sample X to become Y, maknanya the time required untuk X element ni tinggal 40% saja from its initial. That's why dekat sini kita letak 0.4. Sorry. Okay. That's why dekat sini kita letak 0.4 n not X. That's mean final n, okay, n sekarang tinggal 0.4 from its initial n not X. Boleh faham ya? Therefore, we want to calculate what is T, the time required. Okay. Kalau 60% of sample X dah jadi Y nucleus, so sekarang hanya tinggal 40% saja sample X after certain time of T. So kita kira lah. So T here will equal to 63.45 days. Okay, unit days kenapa? Sebab tadi kita pakai day kat sini. Okay, ini adalah per day. Kalau per second, T dia, unit dia seconds lah last kali. Okay, alright. Okay, so finish part 10A1. Okay, sekejap saya highlight dulu jawapan dia. Okay. Okay, question 10A finish. Okay, so now let's look at question 10B1. Okay, tadi 10A. Okay, so now question 10B1. Okay, so we have a sample, okay, of Bi contains 2 exponent 9 nuclei. So give the half-life of Bi is 2.14 minutes. Calculate the initial activity in decays per second. Okay, so we need to find the initial activity A0 and the unit must be in decays per second. So let's write the half-life. So T is equal to 2.14 minutes. Okay, and we want to change to second. Therefore, the half-life is equal to 128.4 seconds. Okay, kira ya macam mana cara nak tukar kepada seconds tu. Okay, so let's write A. Okay, general equation A is equal to dn over dt. Alright, and it's equal to negative lambda n. Okay, so the negative sign means that the number of nuclei present, okay, decreases with time. Okay, so dn over dt, so the number of nuclei present decreases with time. Alright, so remember lambda is decay constant, and how to calculate decay constant? So again, so lambda is equal to ln 2 over half-life. Okay, and it's equal to, in this case, we put in terms of seconds, 128.4. Therefore, lambda is equal to 5.4 exponent negative 3 per second. Okay, so now let's try to solve A0, initial activity. Okay, we want to calculate the initial activity, and it's equal to lambda n naught. Okay, so lambda is equal to 5.4 exponent negative 3. So given that the initial nuclei is 2 exponent 9, okay, and not. Alright, so initial activity will equal to 10.8 exponent 6, okay, decays per second. Okay, so this is the final answer. Okay, and last one. Okay, so the last one is the number of nuclei remaining in 42.8 seconds. So let's say given that T is 42.8 seconds, so we want to know what is the final number of nuclei left ataupun remaining number of nuclei. Okay, so we use generic equation of N equal to N naught, the initial number of nuclei, times E negative lambda T. Okay, so remember the general equation here. Okay, so this is general equation. Alright, so let's substitute the value. N naught is given to exponent 9, E negative, and the decay constant, okay, we have calculated just now in seconds. Okay, kita dah kira dalam unit per seconds, 5.4 exponent negative 3, and T is given 42.8. So, berapa? Kita kira, tekan calculator, and then the number of the nuclei that remains after 42.8 seconds is equal to 1.59 exponent 9 nuclei. Okay, so this is the last questions for set 1. Hope. Okay, so we finished question number 10. So this is the last question for set 1. Okay, untuk sesi final exam preparations bagi SEM 2. Okay, so saya harap kita akan bertemu lagi dalam set yang kedua. Okay, jadinya kalau pelajar-pelajar semua share video ni dan ramai yang tengok lagi, bersemangatlah untuk saya buat video untuk set yang kedua. Okay, so tak lama lagi kita nak final exam. Berapa hari je lagi, kurang daripada 2 minggu. Harap semua buat jadual, harap semua dah mula dah start engine untuk study, dan janganlah asyik termenung sahaja. Okey, mulakan sesuatu, mulakan hari ini dan sekarang. Okey, saya ucapkan selamat berjaya, jumpa lagi. Assalamualaikum dan selamat sejahtera.